Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, and we're here today with Adi Polak talking about her new amazing book that I really love. And it is all about doing machine learning with Spark. So, Adi, why don't you tell us a little bit about sort of your background? And I know that your book actually talks about why you wrote the book, but let's also hear a little bit about that too to start things off, if you're okay with that.
Yeah, I would love to. Well, it's exciting to be here with you today. It's always a pleasure. And thank you so much for, all the insights and the support during writing the book. It takes a village. It truly is a village of good people that, are willing to share from their experience. So why did I write the book? So I guess I should go back to my personal experience. I started my career as a machine learning researcher. I worked for different labs, Deutsche Telekom, IBM, security, and so on. And I still remember the whole good days of Mahout and Hadoop. And also some Teresias algorithms that's from essentially sequence algorithms in C++, which wasn't part of the Hadoop space, but still I was able to bring it to a performance where we could run it on big data. So that was a lot of fun. So starting all the way back in these days and then learning about more the data space and finding myself deepening my experience on building data platforms for big data analytics and machine learning. And really starting from, we have all this great functionality. There's a lot of things that we can do. Of course, there are culprits. Not everything works the way we want it to work. How can we leverage the data infrastructure, the rest of the company, and the people that can come together to really develop state-of-the-art machine learning and make sure we are delivering it to production on time, which, are two different worlds at the end of the day. It's like one of them is, I can build this amazing model, and the other one, how do I get it to production?
Yeah, those are very, very different problems. Sadly, not super overlapping skill sets.
Definitely not. And, one of the things I always advocate for when I speak with data science, and also one of the big reasons why this book was written, is how can people leverage the tools that already exist in their organization? Yeah. And we know Spark is a big one of them, right? There's huge, massive adoption. I don't think there is a company in the world that does analytics or data processing that is not using Spark in some constellation, either through their BI or operational data or what have you. And so a lot of data scientists can tap into the clusters that already exist, the DevOps team, all the different available resources for them in the organization, and kind of build their models and experiments and research leveraging that. Because many times what happens is we go and we try to invent everything from scratch. And then 90% out of machine learning projects are failing because not enough tool, not enough people. It's hard to get the data. So that was the big thing that the book is leading with, is what already exists. How can we leverage that? And how can we bridge out of it if we need to?
Yeah, I really like that context. That's an amazing sort of foundation to pick. It's like, these are the tools that you already have. Like, how can we build awesome things with them? Is an amazing place to start. How did you pick the tools So you like this book is not just about Spark. Obviously, it's about Spark inside of an ecosystem. How did you pick the other tools that you included in this sort of ecosystem to use alongside Spark?
Yeah, it was a huge topic that I had for a very long time. Like, what are people truly using? What will be beneficial? What are the qualities of each one of the tools, pro, cons? If these are open source, what's the size of the community? Integration with Spark was a big thing. Like, how well does it integrate? Does it kind of like a first party integration with Spark, or is it like more of a second, a third party? And throughout this research, I also went back and thought, what did I needed back then in the days? What would be beneficial? So I used that. I interviewed a lot of data science, a lot of folks. And I was also fortunate to work for Microsoft, and we had a lot of information around what customers are using, what are they struggling with, how are they building their machine learning systems. And the truth is, there was a lot of struggles around tools and adding new tools to the mix. Like, every time a team needs to adopt a new tool into their workflows, if it's that experimenting, training, getting your model into a staging environment and getting it to production, or getting real data, fresh data out of production for experiments, this kind of loop always had a lot of friction on what you can do and how you can do it, and also some skill gap between the different parties. Data science it's a different language, essentially.
I mean, sometimes literally as well, different languages, but sometimes figuratively. Both. Yeah, I see that. So like PyTorch and TensorFlow, those were tools that people were frequently using, but struggling with using them alongside Spark when you were writing the book. Yeah,
especially around the data. So loading Parquet data.
Yeah.
Using TensorFlow and PyTorch is not exactly 100% intuitive. There are some tools trying to help folks, but at the end of the day, a lot of companies develop their own type of connectors or build on top of Arrow or things like that. Or they had the process, like, how do you take your Parquet file, you sample it, and then you transfer it into a CSV so you can bring it to your data science. And I see your face, and I'm like, how many times did I do that?
I mean, 100%. I totally see that in production, but it makes me sad. It just makes me sad. Throwing away all that good data, it's a crime. I mean, not actually a crime, but...
Yeah, and format mismatch, right? Because of the different format between CSVs and Parquet. And then you need to have, feature engineering, for example. It's a big thing because you want to have a similar workflow for feature engineering during the experiment and then in production as well. So if you're doing the whole transformation of running feature engineering on top of CSV files, and those have different data types. Yeah. You can see the fun in the inconsistencies.
Oh God. Yeah. Getting the feature engineering also to move from batch to online for inferences is another place that I imagine people struggled with a lot, because you probably have yet another set of types that you're going to get represented in your online queries. Or
it's trying to duplicate the same logic with different tools, at the end of the day, introduce frictions and file format issues and a lot of pain for folks that if different people are implementing it, at the end of the day, it's going to behave a little bit differently.
Yeah. And then you can have these excellent models that everything you've got says it's going to be fantastic. And then when you actually run it, you don't see those results. And that's really disappointing.
Exactly. So I devoted a whole chapter for feature engineering with Spark and the whole thought process around how do you engineer these features and why you need to leverage kind of pipelines and different automation. So these will act the same in production. There are challenges, of course, around running the actual Spark cluster in staging environment versus production,
Of course.
and so on. But at least making it as close as possible can help overcome the mismatch that people are later on seeing in accuracy and their model failing in production, although in development and experiment it worked fantastic. And also in terms of tooling, so Spark is great. There's a lot of machine learning capabilities, right? There's the MLlib, and then there's the ML, and there are probably new features coming up with all the new exciting things around LLVM and so on.
Oh, yeah.
Yet there's still some frictions around the MapReduce, the scheduler.
Yeah.
And this is why the book starts with, hey, here are all the functionalities you have with Spark. Here's how you automated things. And while you're working at it, you can also leverage a lot of the pre-work that you did with Spark on pre-processing and analytics and bridge into PyTorch and TensorFlow. Leveraging Petastorm.
Yeah.
It gives you kind of like a caching capabilities or kind of a translator between Parquet and the rest of the ecosystem. And so midway throughout the book, I'm like, okay, up until now, we leverage everything that's available for us in the organization. Now let's see what are the small things that we can do in order to provide more machine learning capabilities, more algorithms that we can go deeper into the deep learning space.
Yeah.
Leveraging everything that we did so far, including, there's also a chapter around MLflow and how to manage your experiments together with MLflow. So leveraging all of that and then diving into how PyTorch and TensorFlow distributed architecture works that enables people to do deep learning at scale, which is way different than Spark.
Yeah, very different. Very different. I really liked how you use that explanation to explain why there had to be this new method of scheduling, and then talked about the introduction of the scheduler. I thought that was fantastic, because otherwise, I remember like a lot of the Spark community when the gang scheduler was introduced, were just like, why do we need this? I don't understand. And so I wish she'd been around to explain it back when we were debating including the gang scheduler, because it was a fantastic job.
Thank you. I'm glad it resonates. It was, one of my main kind of North Star was, how do I take all these complex things and I simplify it so people can read, understand, and take action. It's always, and you know it better than I do. You wrote multiple books. All are fantastic, and we're truly, a great resource for the industry.
Your book, and I'm super impressed with it, so to me, the interesting problems always exist in sort of like the glue spaces, right? Is one of the expressions. Like, it's the place where we've got these two things that are intersecting, and they're just not quite lining up because neither group is talking to each other. And to me, and I don't know if this is your intention, but to me, it feels like your book is sort of a book which explains to both sides, like, hey, this is what these people are trying to do, and this is how they can do it, and it's not going to fix the fact that, we've got data engineers and data scientists and machine learning folks all doing their own thing. But I think, to me, it develops a lot of like empathy and understanding as well as the technical skills. And I think that's really awesome. And it's really, I know that your primary audience is definitely, or at least I think your primary audience was the ML folks, right? From your introduction, that's what it said. But I think beyond that, even just having data engineers read this book, I think would be super useful for them to get that perspective. I don't know if that was like a secondary thing that you were considering, but that definitely came through to me.
Wow, I never thought about that. Yeah, I think, now that you're saying it, I understand that data engineers can definitely benefit from it, because many times a lot of data engineering folks would find themselves kind of like in these glue spaces.
Yeah.
Enabling other teams to do their work, right? The BI and the data scientists and so on. And so they can definitely leverage that book that speaks about the glue plate, the glue inside the architecture of how we build machine learning systems, kind of like end to end, and think through what they can offer to folks in their organization to be successful building their machine learning experiments, models, and innovation and so on. So that's really interesting. So it's a good point.
So it was not like a conscious target. It's just something that like incidentally came out. Okay. I thought it was fantastic. It's fine if you weren't even trying. That makes it all the more impressive. But like to me, it was something where I was like, I really need to share this with the other people working on the data platform team with me. So, cause one of like, the machine learning platform obviously works on top of the things that we do. And it's like, I want us to have better empathy for our machine learning platform colleagues so that we can understand each other more. How did you pick the target audience? Like, because for me, that's always a big challenge when I'm writing. It's like, who is the archetype who I'm writing to?
It's always a good, it's always what we start with when writing a book. So my target audience when I started was data scientists that want to expand their skills and tools. So people that see that their project is not resonating, they don't get into production on time. They kind of get frustrated because, some data scientists are building state-of-the-art algorithms and they have such a deep understanding into the data space and the domain that they're operating in, yet they're struggling with actually bringing it to life. So those were the folks that I targeted in the beginning, because I used to be one of them and I used to work with them later on when I moved to the data infrastructure side. So I used to build things for them. And I wanted to have that so they will learn the language of the data space as well. So the book is not explaining all the machine learning algorithms. There are some that are a little bit more explained, like deep learning, because it goes deeper into architecture and so on. And how does deep learning actually looks like when I have a distributed system?
Yeah.
But the rest of the algorithm, like logistic regression and so on, the book doesn't go in depth into it. There's an assumption that, hey, there's logistic regression that exists in the world. There's a lot of great books on basics of machine learning, and people can dive into it. So like the audience were data scientists, and now I understand that data engineers would definitely, or infrastructure engineers would definitely benefit from it, so they can kind of speak same language.
That's really cool. So you pick the audience from sort of the talking in many ways to past you is sort of the vibe that I'm getting. Like, this is the book that you wish you had when you were doing these tasks. I love it.
Yeah, and I wish more people on my team would have
also had the book. Yes. Okay. That's also, that makes sense. Part of why I write sometimes is like, I wish other people knew these things so that I didn't have to fix them myself because I am lazy. But also writing to a past version of oneself is I think a super, super great way to write as well. So that's awesome.
Yeah. It's, it gives an holistic view and dives into the important areas where people are usually missing on connecting things. Like I have a whole chapter on deployment at the end. Like what's the difference between real-time, near real-time, batch deployment? How does it look like within a container as a service, as part of existing service? What are the pros and cons? Does it impact the way we build the experiment? Right. Also, there's a question like how those impact each other. If we think through deployment, like, should we plan ahead, like when we're starting the whole experiment? And, I always say yes, like at least have in mind the things that you want to do, because as you go through that path, you're going to hit those roadblocks and it's not going to be pretty. So at least kind of giving people heads up saying, here are the potential roadblocks, here are the pros and cons. When you are making decisions, take those into consideration and, act accordingly, because in software, there's never a perfect project.
No, it's always trade-offs. Yeah.
And then the question is like, how much knowledge do you have in advance? Or do you have?
Yeah, there's the known unknowns and then there's the unknown unknowns. That's the second one, which is just, it's the bane of our existence.
Yeah, it can be a lot of fun and a lot of frustration.
Yeah. Lots of
For sure.
So sorry if this is like kind of a random tangent, but so one of the other things that I really liked about the book was how you took, so there's the optimization algorithms, right, which the machine learning and data scientist folks are already familiar with, but then you also like went in and explained like, hey, now that we're in a distributed model, like the trade-offs are different here, right? And so I love that. And I was wondering, how did you decide to do that?
Yeah, that's a great question. So I looked at a data science that works locally versus what actually happens with the model and building it for, to cover as much use cases and edge cases as possible. And then for building a good, accurate model, it's always best to have a large sample set as possible, rather than taking that perfect Kaggle data set and, oh boy, my code works fantastically, my RAR curve is perfect, my accuracy, RME, and so on. All these good metrics are always perfect. And then I reach the real world and I'm like, oh, this is not actually working the way I expected it to. What is wrong? And so on. And then understanding that every time we take any type of logic, right? At the end of the day, machine learning algorithm is a set of operators that we're running on top of the data, statistical operators, or breaking it down into different CPU, GPU cycles at the end of the day, and understanding that in a distributed world, there's a lot of stochastic operations involved that are not necessarily coming from the algorithm itself. It comes from the machine. Like, oh boy, a machine is down. Oh boy, I lost a message. Oh, different things that can happen. And then say, we need to take it into account when we're looking at error rate and say, when I'm building this, I want to build this so it will be as similar to production as possible. And so I want to train my model on a large data set because Spark is available for me in the organization. And I'm taking these challenges of how different it is those algorithms are being implemented when they are running on one machine versus when they're running on a distributed settings. And I'm baking all of these potential error risks into one place, into a plan. And then I know when I'm executing, its accuracy won't be 95% like we love with Kaggle. But it's probably going to be something around 70%, and we'll be happy with it.
I would sell many things for 70%, which I should not mention on a recorded stream. But yeah.
Yeah, it's, data science always gets frustrated. It's like they do all these great PhDs and research and so on. Like everything is perfect and it just works. And then they reach real world and it's like, oh, what happened to my 95% accuracy and my 5% mistake? And it's like, that's real life now. It's a different ballgame altogether. So it was important to explain that.
Yeah.
And also, I believe it gives people the ability to maybe improve that at some point when they're tweaking their hyperparam, seeds, so on. So they can look into these things and say, oh, this comes from my distributed settings. Maybe I want to have less machines, more machines.
Yeah. And I think, I don't know, maybe I'm just really impressed with because people don't normally think of maybe I want less machines, right? Like that's not something that people think about. And admittedly, as someone who works on distributed systems, it's not something that I think about very often. Normally I'm just no, we get more computers, the problems will go away. But I really like this counterpoint. Sometimes this is not what we need. And so it was really, really awesome to see written down and also explained. So I'm sorry, I just really like that part of your book. I mean, I like a lot of your book. But that part was just, yeah. Oh, that's so good. So good. Okay. The other thing that I'm really curious is how you decided the trade-off of what level of sort of infrastructure information was the right level to include, right? Like you don't have like, hey, like we're going to go set up like a Kubernetes cluster, obviously, because that's like way too far down the stack. But like, how did you decide where these people would probably not have to be worrying about the infrastructure anymore? Was that from your time at Microsoft, or was it from more recent times that you got this sort of gut feeling, or maybe more than a gut feeling?
Yeah, it was. So this is when, having a lot of folks giving feedback and review was an immense help, because I can go deep into the rabbit hole and I would be like, let's do this configurations, and here's a configuration file and you have to tweak so and so and so. But then, great folks are like, you know what? You don't have to explain it. If people want to learn more about their Kubernetes or Docker and how they configure these things, then you should put a link to the documents and saying, here are the docs. You're welcome to read about that. And I think it was fantastic, because then the book is not a 600 pages book. It's more something that is tolerable. And this is like a delicate balance, because some people, I always think like, some people would probably need all these explanations, right? Because they really want to do it right now. Yeah. And so for that, I provided different notebooks for people to run things. So I was like, hey, here, like, I think I ended up with 10 different exercise notebooks, so one for each chapter. And I was like, here you go, take it, try it out. Get your own hands-on experience. Some people asked for, how did I build a Docker image and kind of the files for that. So I provided them with that as well, so they can tweak it and change it according to their environment. So I tried to keep the book as much more
streamlined, but with like sort of accessory resources available to folks.
Yeah. Exactly. Yeah.
This is maybe like super rabbit holey. Did you use like the include tags in ASCII doc to pull in some of those like resources, or were you just like, no, resources are going to sit over here completely separately?
I had the resources separately on a GitHub project and a GitHub repo, and there's a reference to it, and people can, because I realized that some of the people would appreciate like the print edition, and some would want the online. And so print edition can be a little bit tricky. Like if I'm using the print edition, now I need to copy a lot of things. Yeah. So I just rather go to a GitHub repo and clone it and, do whatever. But, I guess different authors, different flavors.
100%. No, I read your book on Kindle because I have too many books to carry around with me that I'm excited about reading, and so it was just like no. Kindle. Actually, I took it with me on my motorcycle trip to read, because I was really curious. I'm very happy. There's also really bad Wi-Fi, so I couldn't go onto the notebooks, but that's okay. I went onto the notebooks once I got back.
Oh, nice! Thank you.
So notebooks separate. Didn't use include tags. I get that 100%. I'm just curious. Mostly because I use a lot of include tags, and I always wonder if I'm overusing include tags or not. And
I have code snippets.
Yeah.
I did add a lot of. Yeah,
I saw them, but I was wondering if you. And so this is like a matter of personal taste as an author, I suppose. Like it's when you want to share the code snippets as like chunks of the same examples that are going to live separately in the GitHub, or if you want to just like create specific snippets that are just for the book. And I never know what the right thing to do is here.
I always think about the reader, right? I always have the reader in mind, what would provide them with the most value and build them for success. So I believe a lot of readers, including myself, likes to run the examples, and it kind of like gets hands-on experience. It's like, I can read it. It's an educational book. I have it on my desk. And, if I'm looking for a term, or if I want to read the chapter and kind of get inspired into new architectures and new ideas and so on, then, I read it end to end, and I just sit with it and read it. And then when I want to take action, sometimes I will dive into the examples in the notebook and say, oh, I remember reading about it. Now I want to
do
copy and paste it, right? So I can run it and then adjust it to my environment, because at the end of the day, as engineers, copy paste is something that we do. And then combined with understanding what it is that we just copy and paste, we can adjust it to our own system. And so that kind of, I believe, gives people the ability to learn from examples, combining theoretical, conceptual, practical side of things.
Another more sort of processy type question. How many times did you have to, did the open source software change while you were writing it and you had to go back and rewrite some of the things that you'd written?
Oh my God. So I did the whole table of content change midway, because I realized at some point I was writing for too advanced. I was like, this book, it would come up being great, but I still need to introduce it to a larger audience, because most of the feedback were, this is great, but it's very hard to understand. You need to have, all these years of experience and knowledge and kind of felt experience from production systems and doing things. And I was like, okay, so I'll start changing. So I redid the whole table of content. I also added a short chapter introducing or refreshing people's memory around Spark, although there's plenty of wonderful books, and one of them is yours. Yours is the best.
No. Thank you. I appreciate it.
And I was like, okay, I'll need to reintroduce it for a little bit, just for the sake of people that are not familiar with the terminology and the architecture and what's available. And so I added that as well. And when I looked into the open source versions, I kind of locked it during that time. I was like, okay, I redid the table of content. There was a couple of major new updates, especially with Spark. I remember Spark 3.1 was released, and this was the last one I introduced. And they realized that, okay, to keep on the timeline, we need to lock it. And so in the GitHub repository and in the books, it states all the versions of the open source that were used, saying, features might change, functionality might change, high-level architecture could change, but less frequently.
Yeah.
And that was it. I was like, okay, 6 months in, I'm locking the versions of the open source.
That's very reasonable. That's very reasonable, because otherwise you can keep coming back to it and just spinning your wheels on it. And you are right. Spark 3.3, we know has some new features for doing machine learning, but fundamentally, the architecture that you describe is still that is probably the one that I would pick, right? Doing in-memory, Pyro serialization between these two is a lovely idea, but in practice, that just hasn't panned out yet. So
yeah, it's always interesting when writing about open sources and technology, when it's not a conceptual book and it's a practical book for people.
Yeah.
How can we provide our readers with the most value, knowing that these products are changing and evolving all the time? And this is where I think emphasizing on the architecture, the concept, the thought process around how to choose the glue within the different products is providing readers with a lot of good information. And a lot of people appreciate that. So it's... No,
100%. I love it. And not everything needs to be the latest version. Because, the latest versions are always great, of course, and fantastic. And please, software developers, keep working. But we don't always want to run the latest version of everything in production. There's some opportunities for improvement, as my boss would also say, with those techniques, of course.
That's really interesting. I just had a conversation at work about, how people runs their open source versions. And I'm like, it takes forever to upgrade. Like, I remember I would take at least a year and a half I worked for corporates, so I guess it's slightly different. But for corporates, when the system is so, heavy, like there's a lot of moving parts, many products that you're supporting, then upgrading to a new version, it's kind of like a big thing.
It is.
So
it is. And yeah, I feel you on the year and a half timeline. We have upgrades that are scheduled for a year, and I am very anxious about those. But I also imagine, like, I remember being at a startup, and that was a totally different vibe. We're like, oh yeah, cool. Let's try out this new software. Eh? Oh, it looks pretty cool. Let's run it in production. Oh no.
Uh-oh.
Oops. I'm sorry.
Roll back.
Oh yeah.
It always depends on how much revenue this product brings.
That's the great thing about a startup with no money. It's like, well, yeah, it went terribly, but it's also not like we made any money yesterday either. So like, So after having written this book, is there another book that you want to write, or are you going to take a break?
It's a big question. It's funny because once I finished it, I was like, oh, I'm done. And then, you're not really done because there's always like editing, typos, images.
Oh, God, yeah.
So I guess for almost 2 months, I thought I was done. And then I realized I wasn't done. I definitely want to write another one. I love the process.
Oh, great.
I love working with the authors community. There's a fantastic authors community, and there's amazing folks in the industry that, happy to provide insights and feedback, which is amazing because always, you need people to work with you on these, kind of your tribe. I don't know yet which one. Like, I've started investigating the whole plugins for generative AI.
Okay.
And I'm fascinated with the opportunities, and I'm starting thinking through, systems for myself, system for doing things, scalable, like more on the engineering side, like how can I make it scalable? What are the opportunities? How can people interact with that better to get the most out of these tools? So this is a thought process that I had. And then, the data space, it's like on the other side of things, the data space has been booming. So, and I have a lot of experience, in that machine learning side, analytics side, but, building data systems, haven't decided.
So we can expect another book. Which book? TBD, but like, this is an experience that was not terrible for you, and so yeah, I'm excited. I look forward to your next book as well, whatever it may be, because this book was just fantastic. I love it, and I really think that for any data engineers out there, you should definitely, you might not be the intended audience, but I think you should definitely check this book out so that you can understand what the machine learning practitioners you're supporting or working with also need. And of course, machine learning practitioners, you should check out this book because you're going to need this so that you can get your stuff into production. And we all love our experiments, but if we're not in production, we're not making money. And unfortunately, under capitalism, we need to make money. So yeehaw. But yeah, Adi, thank you so much for writing this book and taking the time to talk today. That's really, really fantastic. I hope to see you again in San Francisco soon.
Yes.
Yeah. Awesome.
Yes. Coming soon. Yeah, I do have a trip booked. I'll send you the details.
Cool. Sounds good.
Thank you so much for having me. It was a lot of fun. I wish a lot of people would benefit from reading the book and learning and getting hands-on experience and really deepening their skills in the places where it matters. And they're hopefully with the capitalism hat deliver great machine learning projects.
We can only hope.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.